Hello everyone, this is a demonstration video for mouse builder. We will be demonstrating carrier pipelining algorithm first, mouse design using 3DAF in the next, then LFR min file generation, finally guide tool. This is a meter component design in 3DAF. It takes input load and carrier load, and the excess amount of carrier and input will go to the carrier base port and input base port. When multiple meters are combined, it can be pipelined to only have one carrier load and one carrier base, while having multiple input load and input base ports. Meter components in the current LFR are not pipelined, meaning there will be extra carrier loads and carrier waste when there are multiple meter components in the design. Pipelining to reduce these unnecessary nodes is important as it can reduce the number of ports and the cost. In our pipelining algorithm, we traverse each node in a graph to find meters that can be pipelined. When it finds 2 meters that can be pipelined, the first meter will connect to the second meter while deleting the connection to where it was pointed originally, as shown in the image. Then it deletes the carrier load and the carrier waste in the second meter. Using this algorithm, we were able to reduce the total node size from 12 to 10, reducing 70% of original node size. While this may seem small change, it is definitely helpful for large designs that use more meter components. This is a unpipelined DNA digestion graph. As you can see, there's an extra unnecessary carrier load here, carrier waste here, another carrier load, and another carrier waste here. So we want to get rid of that. By running my algorithm, you can delete all the extra carrier ports, and the design becomes much smoother.
This is a transformation LFR file based on design in mouse repository. And I'm going to run this through LFR compiler. And as you can see, it successfully generated the mint file for transformation mint. You can see all the parameters and channels generated. However, the channels are not 100% correct, which we will need to work on in the future. And also generated the transformation dot file, which you can see as a graph, directed graph like this. And now we'd like to demonstrate the 3DAF design using the new meter component. We are now adding the flow channel of transformation design. And now we are adding the control channels. And here we've successfully recreated the design.
From the description in the mouse repository, for example, transformation, we can get the design of it in 3DAF. Then we can download it as a JSON file, and we can upload it into our guide tool. So here we just open it and it looks the same, right? And then we also have done some analysis. So here we can upload another more complex device, and you can see. So that is the motivation for us, because a device that looks like this is very hard to control manually. So we want to have something provide a guidebook for us to automatically control it, or control it manually but quickly. Then we can see the components information here, and then in step 2 we can see where they are, and they are colored here, and via, and just see here. So, but in the step 2 we have the most important task. We need to determine which ports are inlet. So that because that can just help us to do the logic error detection in the step 4 for the simulation function. So here we choose 1, 11, and 12 as our inlet, and all of the left ports will be viewed as outlet. And we can see it by double clicking it. So okay, we can go to the step 3. So now we can see what it looks like, and the simulation pathways for different modes have different pathways. So we can see here, and we can also change the descriptions here, because maybe some of the users don't think our descriptions satisfy their target. So we can just type a string here, and it will be changed. Now we go to the step 4. So we can just choose point 1, 11, and we don't choose 18 or 20 because we don't need any outlet. And just to see what will we get. So it will have a logic error and say there is no outlet. So we need to put in an outlet. 18 is the outlet. So maybe we can do a sequence of operations together. So yeah, you can see the mode 0 has been changed. So we add all of them into it, and we can check it, and that is what we want. And all of them are the simulation pathway, just to show you how to control and what it looks like. And in the stage 0, the mode 0, it is like a new function for you, because if you think we cannot give you, we cannot provide you a very satisfiable or satisfactory pathway, you can DIY it. You can change all of them. So here you can choose if you don't think 3 should be opened, then you can click it and switch off it, just like this. And also you can delete it after you think maybe you think I don't need this now. Okay, so then we have these 3 modes, and we want to operate. What can this guide tool help you? So we go to the next step, and then we can see there is like a set for different ports. What it means. So we can see the 5. Just for example, the 5 and 15. So here, all of them, both of them are opened in mode 2, and both of them are opened in the 3 modes. So they always have the same states in this sequence. So they will be satisfied. They will be assigned to the same solenoid set. So each solenoid, each port in the solenoid will have the same states in different modes with other ports in that. So then it will help us to save more solenoids time and energy while we operate it. And it will form a text file, and we can download it. And we can see what it looks like, and it give you how to control it by on and off, and some functions or some packages in MATLAB can detect this and help we control the device automatically.